So quiz on Monday, and pretty much like we said yesterday, going over the homework was a pretty good review of the things you got to be able to do. This was a continuation of that, this homework, and then today we're going to answer, whatever question, whatever you guys want to talk about. I've got several of them up here that we can do. It's totally up to what you guys would like to see. We got to be able to do the chart, the global max min. With the calculator again, so matter of fact, let's do that. Let's get the hats on. Actually, how it looks. Let's make sure we do the calculator stuff, because as I'm looking at your work, as I'm looking at what you had, of course we got the solutions manual, and you also got the odd ones you can check answers, but my emphasis yesterday was how should your work look? What do you get a point for doing this? You get a point for doing this. You get a point, what I mean? It's still a little sketchy looking at your homework. Now I understand, when it's on the quiz, you're probably going to be a little more careful to, show your work correctly, do things pretty much the way I've been doing them here. At least I hope you do, because that's what you're going to need. Oh, let's get this. Okay, now you should be able to log in. Oops.
Pretty sure mine is a test one.
Test? Yeah. Oh, yeah. Emily Masters.
I swear.
I think you did that before. You did not log back in. I think you did, but you didn't have the hat on. I tried chasing you down the hallway after that. I remember that.
Really?
Yes. You log back in. Here's how you'll know. When you log in after the test, your calculator will restart. So if it doesn't restart, yes, you are. Yes, put the hat on. So get the hat on. Remember, none of this works without the hat on, because. All right. So everybody else. Oh, jeez. Okay. How can I do this? I think I can do this. No. Yes, I can. I can't, because none of the rest. Okay, is your hat on?
Yeah.
I'm not sure it matters when we're there if log in. It only says 7 connected. Okay, now it says 8. Okay, now I'm just curious what happens. Everybody look at your calculators. I'm going to say exit press to test. Is anybody's restarting?
Yeah.
And yours is restarting, but nobody else's is? Yours is restarting? So you might have still been in test mode too. Seemed like maybe there was, I think maybe both of you guys. Because didn't you have a problem that day of the test where it died or something there at the end or something? Weren't you trying to plug it in or something? I don't know, something was wrong.
I think always dies.
Well, okay. So yeah, you and I talked about that. You were going to go plug it in and leave it plugged in and see if it was, and it's always dying, and even though you're charging it.
Yep. It goes from 98 to 50, and the clock period dies. Every time.
Okay. And that's on mine.
Yeah.
Okay. So I'm going to have to train that out. See if we get you the All right. So anyway, let's go ahead and who's this? Will, all right. Oh, see now I already see. That's number 41, isn't it? Okay. What did Will do? And I've had several people ask me about this one this morning already. What did Will do wrong on number 41? Look carefully at the problem. It is square root of 3 x. Okay.
So they don't put the X. That's right.
I agree. I would put the x to the left. Or I would put a dot, or I don't know, or that or something. Right? I agree. The textbook, printers, when they do that, same thing. Why do they write, that? to me that's confusing. To me, that's 1/2 y, not 1/2y. You know, to me, if you want 1/2y, you do that. But I usually on my test try to really make sure that's clear. All right. So, now, with that said, Will, should have been using the calculator on that one anyway. Although I did say do it without a calculator and do it with a calculator to practice, right? But 41 was the whole idea is that's a no calculator one, right? Because now you set that equals 0, you add 3, square root of 3, you divide by 2, you got where does cosecant root 3/2, right?
Well, I use my calculator because I put the x units.
Right, yeah, if you had the x inside, then it's like, I don't know how to do that derivative, right? And then that would be a messy one. Okay? So, again, we'll try to make that very clear when we go to this. So, again, global max min, differential equation problems, derivative, antiderivative rules. Those are the things we have to be able to do for this quiz. So, on section 2.5, what do we look at? I'm guessing 48. 48 is a great example of a differential equation problem with every piece that I want you to do with differential equation included in it. It's got now I'm not saying I'd have a big long problem like this on the quiz, but each of those pieces could be there. I like 48 because it's all in one problem and it kind of shows you an example where a differential equation could be used to describe a real life situation. So I think 48 is a really good problem. Okay, but that's got about everything in it that I might want you to do. And I'll even add one little thing to it that they didn't tell you to do, but they could have easily. So we'll do that one. But anything before that, I've got 9 up here. I've got 24 up here. And we can look at 48. You want any of that? 24. Okay. Let me make one comment about 9, first of all. The reason I threw 9 up here is because of the word IVP. Now, what's IVP mean? Initial value problem. What's that mean? What's an initial value problem? It gives you an initial value, but it's a differential equation with an initial value, right? Understand, IVP means differential equation, right? It's just a differential equation, but they've also given you an initial value. So you can't, if I ask you, I might ask this quiz, define initial value problem. Define IVP, right? It is a differential equation that also gives you an initial condition for the solution, right? For the y. So you have to, so when it says solve this, the solution to a differential equation, is the original function, right? So when it says solve an IVP, they are saying solve a differential equation. So we need the original y, 3x squared plus 5x plus c. And then you put a 2 in for the y, you put a 1 in for the x. Now, I'm not saying you have to show it all of this like this, but it's not a bad idea, right? If I'm taking the test, this is not a bad idea because you've just communicated to me that you know where the 1 goes and you know where the 2 goes. And if you screw it up from here, you've probably earned yourself some points, right? So I don't think it's bad. When I go around and look at your work, some of you, it's pretty scant. There's not much there. When I look at it, I think it looks like you spent about 5 minutes. Now, you may have spent a lot more time than that, but writing-wise, you didn't put much down, okay? So on the quiz, I think it's valuable. Now, I think, am I doing that right? Is that all good? But you're not done when you get there, right? We talked about this yesterday. It feels like you're done. You've solved it. You're in algebra class. You're done. No, now you got to write this like that. That's your solution. Okay, so I just wanted to go through one of those, but there's multiple ones of this we have to do. Okay, 24. So we want to verify this. They're saying, okay, this we think is a solution. So you got to plug this in for y. And then y double prime there. So I need y double prime. So this would be 2x plus x to the negative 2. This would be 2, what's the derivative here, right? I bring the negative one down, that'd be plus, drop that one. What do I got here? Would be minus. Bring that down, minus. So that would go here, so 2 minus 2x to the negative 3 minus, and then I got this fraction, I got x squared. Up here I need 2 times y. Well, 2 times this would be 2x squared minus 2x to the negative 1, right? Take 2 times y right here. Okay, now here I would just split this apart. Remember we talked about splitting apart a fraction if you have a single denominator? I told you there'd be a lot of times this year where it'd be handy to just think of that. Well, this is one of them. So I'm going to split this apart. So 2x squared over x squared, what's that? Well, let me write it. 2x squared over 2x squared, or excuse me, x squared. And then, now we got to be careful, this is minus, so what would this turn into? Plus, this is minus a minus, so that would be 2x to the negative 1 over x squared. Okay, let's keep going. So I got 2 minus 2x to the negative 3. Now what's x squared over x squared? That's just minus 2, and then this will be plus, and then what do we do with these powers? Subtract them. Negative 1 subtract 2, negative 3, and so sure enough, 2 subtract 2, negative this plus this, I get 0, which matches that, so it checks, right? So just algebra, right? I mean, there's a little calculus here. You have to know that you have to do a t-chart. You're trying, this is a solution. We're trying to plug it into there. So you need y double prime to plug in. So I did y double prime, put it there, put the y in, and then I show that the two sides are equal. This work is your justification, right? This work is your justification that it is a solution. It doesn't have to be a t-chart, but this is just a great way to organize it and show that you know what you're doing. Okay, well, let's talk about 48. 48 is just a really good problem. This thing called Torricelli's law. It says, okay, so did you understand the problem? It's like one of those great big Powerade coolers, right? You know, we had the basketball game last night. Mr. Grumbach always puts those coolers right by the ends of the benches, right? Got those big coolers with a spigot down here, right? Now, when does the water come out the fastest? When it's full, right? That's Torricelli's law. That's Torricelli's law. Okay? It says when the valve at the bottom of the tank is open, the depth of the liquid drops at a rate proportional to the square root of the depth of the liquid. So it's going to come down faster because it's going to come out faster when it's full, right? Y is the depth. So the bigger Y is, the bigger this side will be, right? When Y is a bigger number, this side will be bigger, right? The bigger Y is, the bigger this value will be. So that means the bigger Y prime will be, right? So the bigger Y is means the deeper it is, right? The more liquid there is. The more liquid there is, then the depth will drop faster. The rate will be faster. Now it's dropping because they said K was positive. Now let's talk about that. We talked about that yesterday in this problem. Instead of them telling you K positive, I could have said, is K positive here? In this situation, with the water level dropping, what do you know about Y? It's positive, because you got to do the square root of a positive anyway, right? Y is positive, but what else is Y? Decreasing. Y is the depth of the liquid. It's going down. We open the tank, we open the spigot, right? Y is decreasing. Think of the chart. If Y is decreasing, what do you know about Y prime? Y prime's got to be negative. So we know this is negative. We know this is positive. We've already got a negative here, so what's K got to be? K's got to be positive. Now, sometimes I've seen Torricelli's law just with this left off. Well, then what's K? Then K is negative, right? But they like to put the negative there to really emphasize to you this is a negative situation. Okay, so we could have said, now they told us K is positive, but we could have figured that out. Okay, so the bigger K is, the bigger Y, or excuse me, the bigger Y is, the bigger Y prime is. So it's coming out faster. So part A, we just answered part A, right? Now, the explain part, though, is important, right? You would have to do something using this. You'd have to say when Y is bigger, Y prime will be bigger, right? That's why. It comes out faster, not because it's heavier, the water's heavier, gravity, don't give me all that stuff. Based on the differential equation, the water is going to come out faster when Y is bigger. Okay, then it says to verify. Okay, so they tell you, so this is one of those we can't solve. Now you might think it looks like that exponential growth one, but what's different? This is not that bank interest one, right, that we said we memorize. What's different? The square root in it, right, which changes everything, right? And this has a y in it, not an x, so we can't just do an antiderivative. We can't make this y to the 1/2. We can't do an antiderivative, right? So this is just one that they're going to have to tell us a solution, and we'll verify that it is. So they told us that, well, here's the solution. Notice how I made that a 1/4 out in front. I told you I hate divide, so I'm going to do that. So I'm going to write it like that. So they're telling us that's the solution. So we need to verify. So they want us to verify. And they tell you a bunch of other stuff. They say for physical reasons, it's okay to assume that C minus KT is positive. Now we're going to see why here in a second. So when we do the derivative, now you may say, well, why did they even tell me that? Well, there comes a time here where you actually have to pay attention to that. Now you might have got away with it by just totally not even thinking about it and end up getting lucky. But let me show you here. So you bring down the 2, so that'd be 1/2. The inside stays the same. That'd be the first power, and we have to kick out a what? What's multiplied times a t? Negative k. Now, I think it would be smart to bring that negative k around the front with the 1/2. So I'm going to make that negative 1/2 k, and then parentheses c minus kt. You've got to be able to do that. Right? That you've got to be able to do a derivative like that and know that you would kick out that negative k, right? The thing you multiply by the t, right? So that's y prime. So that would go on this side. Negative 1/2 k parentheses c minus kt. Now, right here you can tell that c minus kt would have to be positive because what did we just say about y prime? Y prime's got to be what? Negative, right? And we know k is positive. So right here we got a negative, so the only way y prime can be negative, we already got negative here, is c minus kt's got to be positive. C minus kt, this part's got to be positive. Because remember, we're squaring it up here, right? So it wouldn't have to be positive here. If it's negative here, you square it, you get the same thing, right? So with the squaring, we can't really tell. So down here we can tell. So that's something we'll just kind of keep in our back pocket. And if they wouldn't have told us, we would have had to maybe done some with it. Now on this side we get negative k, and then we get the square root of 1/4 c minus kt squared. Well, what happens when you do the square root of that? Well, the square root of 1/4 is 1/2, and the square root of that squared is c minus kt. And again, it's okay to do the square root of something squared as long as you know that something was positive. And that's why that's one of the reasons knowing c minus kt is positive is okay. Okay, it's typically just because you do square root of, right, 3 squared, you say, well, that equals 3. Well, what about this? What about the square root of negative 3 squared? Is that negative 3? The square root of negative 3 squared, is that negative 3? No, it's not. Because negative 3 squared is 9, and the square root of 9 is 3. Not negative 3. See, so if this thing in here is negative that you're squaring and you do the square root of it, you don't get that back. You get the absolute value of that. So that's where we would have run into trouble. But since we know c minus kt is positive, we just do it. Like I said, you might not even have thought of it. You could just taken the square off, and technically that might not have been right. Now we're done. I just rearrange it a little bit so it looks the same. But sure enough, we get a match. Okay, so there you go. So there's part B. It just verified it. Now we can move on to the next phase of the problem, because this is how a differential equation problem typically looks. A differential equation problem, typically you solve the differential equation, but we don't know how really to solve very many right now. We did on number 9, right? We solved that one, okay? But on this one, we don't know how to solve it, so they had to give us a solution. But we verified that it was a solution so we could feel more comfortable about it, right? Because you'd be bothered about, right? You'd say, I don't really trust that that's a solution. But now we know, right? We verified, so you can sleep better at night. All right, so now we know that that's a solution, so now we can go ahead and use it, right? But we've got these C and K, these things we don't know. And they said, well, let me tell you a little bit about the tank. What did this tell us right here? It's feet, I think. There's 9 feet. Oh, this is a big tank. This isn't one of those coolers at the thing. This is a great big tank, right? This is 9 foot. The water level is 9 foot deep at the beginning. So they're saying this particular tank, there's 9 feet of water in there. And then what do they tell you? What does this tell you? 20 minutes later, 4 feet. So they're telling us enough about, we now know enough about how fast it's draining that we can now figure out how much water's in the tank at any time. But we've got to now plug these in. So they give us 2, and they have to give us 2 initial conditions because they're 2 unknowns, right? So we put the first one in, and so we get 9 here, we get 1/4 C minus K times 0, right, which is nice because that makes that go away. We get 9 equals 1/4 C squared. We get C squared equals 36. We get C equals 6, right? So you can see how when I looked at your work on number 48, a lot of you, it was kind of lacking maybe a little bit, some of this, right? We need to have this stuff. So now we know what C is. So now we kind of go to the next step. So I'm going to rewrite it. I now know that C is a 6, so I now have this. All right, so now I've got my solution to be that. Well, now what can I do? Put a 4 in for Y, put a 20 in for T, and now go to this. Now here, this is a little different. So on this one's easy because that means 0. But here, I think, what would you suggest doing first here? Let's multiply that 4 over there. We get 16. And then we get 6 minus 20K squared. Now we could square root both sides. Now here's another time. Right here, we should put plus or minus 4 right there. Right? We should put plus or minus 4. Anytime you square root both sides of an equation, you should put plus or minus. But why don't we need to? Because this right here is C minus KT. Right? Right here is C minus KT. What do we say about C minus KT? Gotta be positive. So it can't be negative, right? So that's why we can just do the square root of both sides and just get a 4 and not do plus or minus. All right, take away 6. 3K equals 110. Okay, good. Oh, back here. I should have done the same thing. Right here. I should have mentioned that. Why didn't we do plus or minus 6 right here? Right? The reason we didn't do plus or minus 6 is C has to be positive. Because think about it. Back here on C minus KT is positive. That means C would have to be greater than KT. Right? Well, what do we know about K? Positive. Time positive. So this is positive. So C has to be greater than that. So C has to be positive. Right? The only way C can be greater than positive is it's also positive. It can't be negative. So we know C has to be a positive. Okay, so right there, again, that should have bothered you. That should have bothered you when I did square root here and got just 6. That should have bothered you that I didn't put plus or minus 6 right there. Right? Because normally you would have to. Normally you would have to. But in this problem, because of what we said here, we know that it can't be negative 6. Okay, so we get K is 110. So we're rolling along here. So now we got our actual solution. Here is now the solution to this particular tank. This is the depth of the tank at any time t. Okay, and now we can go on and answer the question. It says, show that the tank takes 60 minutes to empty. So what do? 60 for t. 6 minus 6 is 0. You get y equals 0. The depth is 0. So it's 60 minutes to tank it. Or they could have said, how long does it take for the tank to empty? And you'd have done what? 0 for y, that's all. Right? Or how much water is in the tank at 40 minutes? Or what time is there 6 feet in the tank? Or whatever, right? So I could ask you all kinds of questions. But that's the whole point of a differential equation problem is we can describe the situation, but this equation is not useful. The differential equation is not useful for finding how much water is in the tank, but it's useful for describing in a pretty simple little equation. It's useful for describing the situation, right? All right. So we got that. And then E, when is the water level dropping at a rate of 0.1 feet per minute? So where would you plug the 0.1? prime. Isn't that y prime? That's the rate the water level's dropping. That's what y prime is. Well, we got a couple different y primes. We got one here, and we got one here, and we now know what C and K are. Which y prime would you rather use? The one that's got a T in it, right? Because it says at what time. Because here, that doesn't have time in it. We'd find a y, and then we'd have to plug that into our y to get the time. So we might as well use this one over here, okay? So that would be, so y prime was, well, we can just do it on this one. Bring that down in front, 1/2, 6 minus 1/10 t to the first, and kick out a negative 1/10, right? Like that. Okay, so that'd be y prime would equal negative 1/20, 6 minus 1/10 t. And I have to plug what in here for y prime? Actually, that's wrong, but you're really close. I kind of tricked you. That's wrong. What's wrong with that?
Oh, that would be
No, the point one's in the right place. The point one is the rate the water level is dropping. That'd be negative point one. That'd be negative point one, right? We said at the very beginning, what's y prime? Y prime's negative, right? Y prime's negative, okay? So now you multiply your negative 20 over here, you get 2 equals 6 minus 1/10 t. Well, the rest of this is just algebra. And, once you get t equals 40, at 40 minutes, it's dropping at 0.1, right? So you plug that 0.1 with the y prime and you solve. Okay, the only thing that wasn't in this problem, and I'm going to give you an example of one to do for tomorrow that you can do, but I said I want you to put into words and be able to write a differential equation. So with their first sentence, okay, look at 48 now. With their first sentence, they said when the valve is open, the bottom of a tank, the depth of liquid in the tank drops at a rate proportional to the square root of the depth of the liquid. Okay, I could give you that sentence, and I would expect you to write. Now, I might tell you, let y be the depth of the liquid. So if I just said, let y be the depth of the liquid in the tank, the depth of the liquid drops at a rate proportional to the square root of the depth of the liquid. Write that differential equation. Oh, okay. So y is the depth of the liquid. The rate that the depth of the liquid drops, well, that's y prime, because that's a rate, is proportional to, that means put a k, the square root of the depth of the liquid. Right? You should be all right. And you don't need the negative, because in mine, k would be negative, right? So this would be a good answer. That would be it. So I want you to be given a sentence like that. You need to be able to write that. Okay? All right. So that's differential equation stuff. Next section, number 10. Somebody was asked about this earlier. This is another solve the IVP. Solve the IVP. Now the focus here is on these exponentials, so it's a little harder. It's a little harder one to do. 11's the same thing, but this says solve the IVP because they give you initial condition. Well, we've done this, but let's practice one more time. So that means find the original equation y. So what's the antiderivative of 3e to the x? 3e to the x. What's the antiderivative of 3 to the x? Ooh, that's weird. What's the derivative of 3 to the x? The derivative is 3 to the x ln 3, right? So we want something here so that when we do the derivative, it gives us this. Well, the problem is if I just put 3 to the x here, when I do the derivative of that, there should be an ln 3 set there. So there must be a 1 over ln 3 setting there, right? So now when I do the derivative of 3 to the x, I get 3 to the x ln 3, and then this 1 over ln 3 is sitting there, they cancel, and away you go. What's the antiderivative of 1? X plus c. Now we put our initial condition in. We put a 0 in for y, we put a 0 in for x. So, e to the 0 is 1, so this would be 3. 3 to the 0 is 1, so this would be 1 over ln 3 plus c. So we solve for c. C would equal, if I add that over, that would be 1 over ln 3, and then subtract the 3, so c would equal that. So my final answer, put it in red, would be, I'm lucky I can erase, okay, easier than you guys. So it's, in place of my c, I'm going to put 1 over ln 3 minus 3. Why go to a decimal on that? Who cares? Probably a no calculator problem anyway. For sure it would be. And there's your answer. So when you solve an initial value problem, you're finding the original function, but there won't be a c in it because they give you an initial condition that helps you find the c. On 11, and so this is the only reason I put these up here. On 11, it says solve the DE. Well, why did, on 10 it said solve the IVP, on 11 it said solve the DE? What's the difference? No initial condition, so it's not called initial value problem. There's no initial condition, so our final answer will have a plus C in it, right? So this one, it's the same problem though, isn't it? I mean, basically, you know there's going to be a 2 to the x, there's going to be a 1 over ln2 setting there, and then the antiderivative of 2 is 2x, and then there's going to be a plus c, right? I mean, it's almost exactly the same problem, but there's no initial condition to plug in to find the c. So this is called your general solution to this antiderivative, or to this differential equation. Here we found a specific solution, like so. All right, here's 14. I just worked it out. I don't know. I guess I don't have a lot new to do here, so it might be worth spending some time. But I do want to try to give you some work time here today. So wasn't this what they had in 14? Oh, is it a solution? Okay, so, I know why I wanted to talk about this one. Okay, so is it a solution to this initial value problem? So it's just a verify problem, right? But the difference is you have to verify two parts, because when they give you the initial condition, they say, okay, is this a solution? So you not only have to see if this solution works over here, you got to make sure the initial condition works in there too. Okay, does that make sense? So they give you this solution. So, but they also give you this. So I needed to come over here and plug in a 0. So e to the 0 would just be, where did I do that at? Oh, I did it down here. So I plugged in a 0 in for t right here. See? And I got e to the 0, which is 1, and then so 100 plus 50, that would be 150. So sure enough, when I plug in a 0, I do get 150. So I needed to do this extra little piece over here. Hey, that looks like the rest. We got to do this little extra piece right here. Okay? When it's an initial value problem. So we still have to do our t-chart. So I had to still do, here's our y. I did my y prime, the 100 would disappear. We have to kick out a 2 here, so that'd give me that. So I put that over here for my y prime, and then for my y, I put that right there. There's my y, okay? And so the hundreds canceled, and then 2 times 50, I get that, and that matches that, so it checks, okay? So it's just a verify problem, but we also had to put our initial condition, and I knew to put it into the y equation because that's what it says. It says y of 0. So I plugged a 0 in for t and 150 in for y, and I did that right down here. So you got to do both parts. So that's something that's maybe not a thought. Okay, 55 was just another verify, and then so this is a little different scenario than a regular bank interest because they're going to take out a $100 fee. So this is not the memorized one. This is not the regular bank interest one. So that's why they had to tell you the solution. So again, I can't do enough of these verify ones, I guess. I want to make sure you do it. That'll go away. Here you have to kick out a 0.1. That'll be e to the 0.1t, and you'll multiply by a 0.1. Okay, so that's p prime. I'll put that around front. 0.1c e to the 0.1t. And then here you'd have 0.1, and then for p, we'd have 1,000. Plus c e to the 0.1t, and then minus 100. Well, when you distribute there, that's 100 plus 0.1 C e to the 0.1 t minus 100. The hundreds cancel. Sure enough, it checks. Right? So you got to be able to do this verified. I mean, I don't know, I feel like I've done 50 of them in the last 3 days. Right? So hopefully that's feeling better. And then the last one says, so what if 2,000 was deposited? How much will it be worth in 10 years? Well, that's where you just do this right here, right? So you put a 0 in for T. So if you do deposit 1,000 right now, and that, or 2,000, and that's where some people say, well, isn't that the C, the 2,000, like the A yesterday? No, it's not. You put the 2,000 here at times 0. So e to the 0, of course, is just 1. So this is C plus 1,000. And over here we get 2,000. So C is 1,000. So now your equations, P equals 1,000 plus 1,000 e to the 0.1 t. So there's your P equation. So how much is it worth in 10 years? We put a 10 in for t. Away you go. Okay, so again, very similar to this, like Torricelli's law. Going to be that kind of, for sure you're going to have something like that as a differential equation. I'm going to give you a differential equation. You know, I'm going to probably give you something to solve, somewhere you can just do the antiderivative. Did a couple of those. But there's going to be some where I just give you the solution, right? Or it's that one we memorize, like the bank interest maybe. Okay, but it could just be this, and I give it to you. You got to plug in some initial conditions, which is what they gave you there, the $2,000 at times 0. That's an initial condition. And let us find the C, and then answer some question. How much water's in the tank after 20 minutes? How much money's in the bank after 10 years? Right? I mean, so you just have to get your equation, get your solution, find your C, answer some questions about it. Yes, ma'am.
Can we do one of the A?
Do what?
What was the A, like the compound interest of the project? Like the one that we were supposed to.
You mean like what would it look like?
Yeah, well, I don't know where you put, what you put in for the.
Well, I mean, the thing you got to remember is it has to look like that, right? So then that solution is just this, right? That right there. So if I give you a bank, say there's 5% interest, right? They would give you this right here, right? So you have to know then that that's y equals AE to the 0.05 t. That's your. So it's very similar to this one, right? So if they say that you put in $20,000 in the bank, where does that go? Well, y is the amount of money, right? Y is the amount of money. So the 20,000's got to go right there, right? And then what goes here? Whatever year you put in the 20,000, right? So if you put in the 20,000 now, you put a 0 in, right? So the T is, so your question is you don't know where the things go. Well, Y is the money and T is the time. That's the only place there is something. The K will have to be given to you in the problem. It's usually the interest rate, but a lot of times they just give it to you. And then you get an initial condition, you find A. So it's just like any of this, you get an initial condition and you find the C, so it's just the same. It's just, all you got to know is just that this, if your differential equation looks like that, then you know it's that. In the other problems, I give it to you. Here, the differential equation is this, and I had to give you that because we don't know what the solution is.
So when you figure out that answer right there, so when you find, like on the other one, when you find A.
When you find what A is, which in this e to the 0 is 1, so A is just going to be 20,000. So it's going to turn out that the A is just 20,000. And then it's e to the 0.05 t, right? Right, because e to the 0 is 1. So 1A is 20,000. So we just found out A is 20,000. And now 10 years later, put a 10 there. When will you have 100,000? Put 100,000 here and solve it. Which those would be calculated, right? I mean, obviously, to be able to find out that value, you're going to use your calculator on something like that. Okay? All right, 41, so this was the problem. You notice that I really tried to emphasize when I wrote it that I put the X way out here. You know, I think when you look at 41, it is close, I agree. But if you look carefully at it, that X is not under that square root sign. They do that with a lot of things, you're right. Or some books do. And I agree, I think they should. But they don't always, which they did here. So, G prime would just be this. Cosine is square root of 3 over 2. Right? Square root of 3 over 2. Where's cosine square root of 3 over 2? Well, cosine is positive in this quadrant and this quadrant. I believe that's pi 6, right? And then this one would be 11 pi 6 would be the other one over here. So, and I'm pretty sure it said between 0 and 2 pi, didn't it? Okay. 0 and 2 pi, so I'm not going to, I want to give you some work time here, so I'm not going to go all through this because we did, this is just the same exact thing we did yesterday and the day before. So we're going to do a number line. So we're going to pick some numbers here, so that'd be in between, pi would be in between, 2 pi would be in between. We're going to plug those into our derivative here, which is right here. Now, if this is no calculator problem, it's probably a good idea to know that that's like, no, that's not right. Square root of 3 is like 1.7 something, right? I mean, it's not square root of 4, which is 2, and square root of 2 is 1.4 something, and square root of 3 is around 1.7. Probably not an issue. You put a 0 in, you get cosine. Well, I guess it probably is an issue here. You put in 0, cosine 0 is 1, so you get 2 minus. But you got to know that 2 is bigger than square root of 3, right? 2 is square root of 4. So 2 is definitely bigger than square root of 3. So 2 minus square root of 3 is going to be positive. Put in a pi, that's negative 1. So you'd have negative 2 minus square root of 3. Well, that's clearly negative. And then put in 2 pi, cosine of 2 pi is 1. And again, so you get the same thing. So again, we have that. So from there comes all your local max min answers. Don't forget to justify. This is a local max. Since f prime changes positive to negative, f changes increasing to decreasing. You know, just answer whatever the questions may be. In this problem, you're supposed to find the local max, find the local min. Okay? You're also supposed to do global max min. Now, here's what I don't want you to do. Is just because this is what we did on this problem on the quiz, if I ask you for the local max min, don't give me everything. Don't give me the global max min too, right? If I don't ask for it, I don't want that. Okay? So, you know, I'm not going to know what was your answer. Is your answer just the local max min, or do you think the global max mins are also local max mins, right? I mean, answer the question. If the question says, where is f increasing, answer that question. Don't give me local maxes and mins, right? But if I ask for local max and mins, I don't want them. It's all there, but in this number line, it's all there. So whatever I ask for, you can get from there. Okay? And if you're supposed to do inflection points, now you need the second derivative, right? So you do the derivative of that, and I should not have labeled that as f prime. I should have labeled that g. G double prime is negative 2 sine x. So where does that equal 0? Well, we can divide by negative 2. That means our sine is 0, so that's at 0 and pi. 2 pi, right? And so I can make a number line, put those on it, and plug that back into my second derivative.
Wait, what happened to the root 3?
It's a number. So the square root of a number is just 0. The square root of 7. Yeah. Square root of 7, or I mean 7, the derivative of 7 is just 0. Yeah, square root of 3 is just a number. While I'm thinking of it, what's the derivative of ln4? Gotcha, Will. Gotcha. What's the derivative of ln x? 1 over x. What's the derivative of ln4? 0, because ln4 is a number. ln4 is not a function, right? The ln x function, the derivative is 1 over x. The derivative of ln4 is 0, because ln4 is a number. So it'd be like asking, what's the derivative of x squared? 2x. What's the derivative of 7 squared? 0, right? Because you're asking for the derivative of 49, and the derivative of 49 is 0, okay? The slope of 49, at y equals 49, the horizontal line, the slope is 0, right? But x squared, different story, okay? So anyway, that's kind of related. Then, if I did want global max min, then list of candidates, right? F of 0, G of 0, G of 2 pi, G of pi 6, and G of 11 pi 6. But you got the answers, you can look those up. You would do your list of candidates, you would plug those back into the original, because you're trying to find where G is its highest y value and where G has its lowest y value. And so you're plugging into G to find those values. Here you're plugging into G prime because you want to know if G prime is positive or negative. Here you want to know if G double prime is concave up or concave down. Or if G is concave up or concave down, so you want to find out if G double prime is positive or negative. And so you plug into G double prime when you do that number. Okay? All right, and then 45 was the thing with the calculator. Oops. So let's just quick, I'm not gonna go through this whole problem again. Again, you've got the answers there, and you can work on it. I can help you if you've got some questions. Talk about local max min and talk about flex point. So we're gonna need F prime. So one last time here, before I let you work on some stuff. That's gonna be negative sine x. So go ahead and type this into your calculator, Will. Type in F. Just type in F. And then let's type in the derivative. This would be minus, we're going to kick out a 2, so that'll cancel that 1/2, won't it? What's that? Yeah, just type in F. Just type in F, because we're going to plug into it here in a minute. So, and then type in this, because remember, we would kick out a 2 here. So we'd have negative 1/2 sine 2x, and then we'd kick out a 2, so the 2's would cancel. So there's our derivative. And our second derivative is going to be negative cosine x minus 2 cosine 2x, I think. Okay, so let's go back to the calculator. So he's, okay, well, we're not going to type anything in right now. Just hit enter. So that's the original function right there. Now notice how it rewrote it even, but who cares, whatever. We know that's the original function. So remind everybody how to do the derivative. Okay, and let's do the derivative of that. So it's by the 9, it's next to the 9 right there. And the derivative of that. Let me see your calculator. Is it dead, Tim?
Yeah.
Because you're not going along with this. Just die. Shuts up. Alright. So there's our first derivative, second derivative, third derivative. Okay, so now what do we want to do? We want to do the first derivative equals 0. So remind us how to do that. Now what's he missing? Trying to solve, right? We're doing, okay, well, but that's your original function anyway, isn't it? We want to do this. We want to do the derivative equals 0 and find our stationary points. Okay. So you can type it in, or it's under menu and algebra, either way. You need parentheses around your solving. Escape. Well, yeah. You need, right there, you need left parenthesis. Okay. Need an equation. You need an equation. See, this is what I'm talking about. So you've got to be able, because, right? If you go to do this on the quiz on Monday and your calculator is giving you all kinds of weird stuff, I'm not bailing you out here. We got to be able to do it. So what to help him out? Kind of putting him on the spot here, but. Okay. Well, let's. Yeah, keep going. Let's just keep going. Go go ahead and do this. We'll see what kind of error message we get. We'll see if we can decipher it, because that might be what some of you need to do. If you don't know how to put in your calculator, then you're going to have to decipher the error message you get to try to fix it. Okay, so we're between 0 and 2 pi here is where we want to be. Is it 0 and 5? Oh, this is 45, right? This is between 0 and 5. Okay. Hit enter. Okay. Too few arguments. What's an argument? Well, in a function, which is the solve function that we're doing right now, it's got to have several entries into it. The solve function has to have an equation, and you have to tell it what you want to solve for. So inside of the solve parentheses, you need to have an equation and then a comma x. What's wrong with what he's got? Well,
This comma x is outside.
this vertical bar is okay, but his z equals 0 and his comma x are not inside the solve parentheses. They're not inside. And where are the solve parentheses? Well, here's how you would look at it. You'd see solve, you'd see this left parenthesis. This left goes with that right, this left goes with that right, this right goes with that. So there's my solve. So I've got to have it inside the solve, and the comma x has to be inside the solve. So those are the two arguments of the solve. The vertical bar goes outside of the solve. The vertical bar goes outside of the solve. Okay, and now this one didn't give us decimals. Yesterday it gave us decimal answers. So remember what we did? We kept like 6 or 7 of them and wrote them down, because we might have to plug those back in later. Okay, but that's fine if you want them, but I like these better. I'd rather have these. I'm glad it gave me those. That's good, but plan on possibly getting decimals too, so understand that. So it gave us 4 of them, so we actually have 4 of them that we have to deal with here. Okay, now keep in mind, when we talked about local max min, I told you that we would not have, pi and 4 pi thirds? Local max min, remember, are not at endpoints. So this goes from 0 to 5. So if we're doing local max, 0 is not going to be one of them that I include. Now I probably won't count off for that if you do it. But then you're going to want a number line for f prime. I didn't leave myself enough room, but you got 0, you got 2 pi thirds, you got pi, you got 4 pi thirds. Okay. Now what are some numbers you can plug in? Well, 5 would be over here. Here you don't really have anything you can plug on this side, because we're talking about 0 to 5. Now you could put a -1 or something, I suppose, in, since it's calculator. But I don't even think I'd plug anything in over here. We're only looking from 0 to 5, and so that's kind of like your hard left edge. I wouldn't call that a max min. So what's between here? Well, pi thirds. Let me put that in blue. So you can do pi thirds. What's between 2 pi thirds and 3 pi thirds? What would you put in there? 5 pi 6 would be one. That'd be a good one. You could also get decimals. You could look at 2 pi thirds and see what that is as a decimal. Okay, and then you could put something in between there. Like I think it's about 2 point something. This is 3.14, so like 2.5 you could put in. So you could actually write those as decimals since you're using your calculator. But 5 pi 6 would work. This would be 5 pi 6 would no, that's all right. 7 pi 6. 7 pi 6 would be something in between there. But again, you could use decimals too. Okay, so let's put those in. Let's put pi thirds. Let's put 5 pi 6, 7 pi 6, and 5. So back to our calculator. So this is the other vertical bar we used, except this time, well, you tell me. So we want to put this into our derivative. So go up and grab the derivative, which is that one. And we want to plug in a pi thirds. That's the first one we want to plug in. So what do? This is where we do the vertical bar without a solve or anything. We're not solving anything. Here we're plugging it into the x. Okay, so that's a difference. Solving is one thing. Plugging into is another. Now Will wants to do the brackets. That's good. He can do them all at once. It was just pi thirds, I think. We weren't going to do 0 either. I think if we go back to our number line, 0 was not one of our things. We were going to plug in pi thirds, 5 pi 6, 7 pi 6, and 5 is what we were going to plug in. Why do I plug in what? I'm not plugging in pi.
No, 5.
Well, okay, 0 was one of my answers here. Okay, see, this is where it comes back to these tick marks. Okay, these are my, right? These are my stationary points. I need numbers in between. 4 pi thirds is like 4 point something. I need a number bigger than 4 point something to plug in. So I can plug 5. Now I know it's at an end, but I can plug in a 5. Here, I would need to plug in, I don't plug in 0 because I don't plug in any of these tick mark numbers. I always plug something in between. What I said was I'm not going to plug in like a -1 or anything because I don't care what the function's doing on this side of 0 or on this side of 5. That's the difference, okay? But if you like it better, you can plug in a 4.9. It'd be fun. So you plug in way too many things. We're only plugging in the blue things. We're only plugging in the things in between. We want to know if this is positive or negative, positive or negative, positive or negative, positive or negative. So we're only plugging these in. See, that's can be the problem when you do the curly brackets. I was a little nervous about showing people that, but I remember I said, only do it if you really know what you're doing and you really understand what's going on. We're trying to see if f prime is positive or negative. That's what we want, right? So if you get so confused by the calculator that you forget what the heck you're doing on the chart, that's not a good thing, okay? So we're wanting to put a pi thirds in here. Matter of fact, geez, it just dawned on me. Do we even need the calculator here when we got a nice number like pi thirds? By the time he gets all that punched in, couldn't I have just done sine of pi thirds? I mean, maybe if you don't feel comfortable with those values, then maybe that's not a good idea, right? But sine of pi thirds is what? Root 3 over 2? And this would be sine of 2 pi thirds, which is also root 3 over 2, right? And so this would be negative root 3 over 2 minus root 3 over 2. Isn't that got to be a negative, right? So I think I just did it. I think I did it faster than if I used a calculator, but whatever, that's fine. So look what he got. He got negative. He got a, what's this? What's root 3 over 2? Hit control enter. Hit control enter. Now, is 5 pi thirds right here? That would be bigger than 4 pi thirds, right? So that's fine. 5 pi thirds is good. So he's got negative, he's got positive. Now scroll to the right. Arrow up there and then scroll to the right. So it looks like you got negative, positive, negative, positive. Okay? All right. Negative, positive, negative, positive. Okay? Yes?
So if you didn't do the brackets, like, would you just do the vertical bar x equals and then the number?
Yeah. So, yeah, arrow up there and do that real quick, Will. Right, you grab that. And then delete that bracket you got there. And then right here, you just do x equals pi thirds. Or whatever you're plugging in, 1. If you're plugging in 1. Okay, and that gave you a negative, Emily. So then you come here and put a negative. And then you come over here. And now you arrow up. Grab that. Delete the pi thirds. What was the next one we wanted to put in? 5 pi 6. So then you delete that, put in 5 pi 6. Okay. And then you get a positive. Right? Hit control enter just to double check, just to make sure you know that's positive. Yeah. Okay? Alright. See, that's why it's so important. The calculator is just a tool for doing this stuff. I'm not trying to teach you how to use the calculator. You gotta, you gotta have forest for the trees, right? You've got to understand what are you trying to do here. You've got an f prime. We're trying to see when f prime is positive and negative, so we know when f is increasing and decreasing, because that can tell us local max and min, right? So we just need to, so putting these on a number line is like where it's crossing the x-axis, right? Then we want to see if f prime is above or below. So we just need to pick some numbers in between, and we need to plug those into f prime. Well, if it's a complicated equation, we may need our calculator to plug in those values, okay? And so, I've shown you some ways to let your calculator do that, but we can't get too caught up in it. And then it's exactly the same thing for f double prime, right? Exactly the same thing. You solve that, set it equal to 0, find those values, put them on your number line, pick numbers in between, plug those in, see if you got positive or negative. Those would be inflection points because f double prime would be changing concavity, okay? And you can answer because that's what the next part of 45 was that. Okay, I just put, there's not a lot more to do. I mean, you could go back and redo the last couple homework assignments, it would be good. I tried, I've used up most of the problems in the book. So, 46 is another one, just like 45 was, with the calculator. So I just have a few more. This is whatever you want to do to review for the quiz. Go back and watch videos from the last couple days. These are some problems. These aren't necessarily, quiz. I mean, they have something to do with the quiz, right? I mean, those are in the review section at the end of the chapter. I just tried to go through there and find some that were closely related to, some quiz ideas, but don't think that these problems here is everything on the quiz, right? If you do these problems, you've reviewed everything that's on the quiz. No, this is just some additional practice on some of the things on the quiz. You got to think back to what we've done all week. I think over the last couple of days, we have hit on everything, for sure, that you want to be able to do. Okay? So let's use the last 20 minutes. You can work on this. If you've got something on your homework that was really bugging you that you're still not sure about, this would be a great time to ask me about it. So, Tim, you're telling me you take this home, you plug it in, nothing, and it seems charged and it just dies. Huh.
It goes from fully charged to half charged and over to flat.
Huh. Okay, well, I think I've got an extra battery. I don't think I have it. Let me just switch calculators with you. This one's probably going to be dead here when I charge. Well, maybe. It's possible this. Well, if this doesn't work, then it's probably a bad calculator. Oh, no, that looks like it's kind of bulging. It's gonna explode on us. So Max would just plan on being ready to go Monday?
Yeah. I'll do all those assignments right to finish.
Last 2 days you've seen.
You have the answer. You figured like 2.5, 2.6.
Right here. All right, should be good to go. Looks like it's variable charge, so let's see if that keeps you charged. Wouldn't hurt to charge it more before Monday. Everybody, there will be a calculator part for sure, as we've been talking about, so make sure your calculator's in charge. You bring it, because I probably will not have any, none of mine are charged. What's that? 44.
It's when we have to write, they give you like a scenario. You can write
right? So what's your question?
So it's equal to Y prime, isn't it, because it's the rate?
Okay, well, you wouldn't use Y because they tell you what to use in the problem.
Would you use the rate 0,
O for oil.
so O prime?
Well, O is what's it say O is?
Um, oil prime.
No, no, very last few words.
Oil and the temperature times
Yeah. It says, write a difference equation satisfied by the function O of T, comma, the amount of oil in the tank. O is the amount of oil in the tank, like feet or barrels or, I don't know, it didn't really say. Okay, so what would be the rate? So that would be O prime, yeah, so that's O prime. Right. So the
Yes.
rate
It says
is proportional to,
times K.
so what do you got? So what do you have so far? So read me what you have.
O prime T equals K.
Proportional to what? The amount of oil in the well, in the tank.
So just,
And you don't even need O prime of T, you just put O.
so it's O prime T equals K times O.
Right. Which is actually that,
It's just Y prime equals K.
it's just Y prime equals KY. That's that one we would memorize. So now you don't have to do that. You're done with that problem. Right now, you're done. But the solution to that would be O equals AE to the KT. Because that is the one we said we memorized. The rate is proportional to the amount. That's the compounded interest.
So 12 feet.
Yeah.
You're given this.
Yeah.
You're given like
Why prime
You
equals
pick
paper?
this,
Which is that?
and then from here, can you find the reflection coefficient? Can you pick one of this?
We can, but I,
The A.
well, it doesn't matter, A is just a number that's gonna set out front, but you do know the A because it's right here. You can plug 100 in for Y, and you can put a 0 in for T, and you get zeros and ones, so A is gonna be 100. So based on that,
And then from that, you can just go, then you multiply the 100 by 1/6, whatever that is, 6.
say, 0.060.
Yeah.
The inside.
Oh, okay, and then you just plug
Kick out the
sides.
0.06. You kick out the 0.06, but you also leave it